Ciphers. Ciphers can be attacked in many ways. They can be attacked by frequency analysis and pattern words and chosen ciphertext attacks. You're going to see several questions, and the answers are likely going to be chosen ciphertext attacks. But what are these things? Let's go through here. If they don't explain it, we'll come back. We'll circle back to these. If the attacker is able to decrypt some parts of a message, then chosen ciphertext attacks are now possible because he can use those same words and keep encrypting them until he sees the same encrypting pattern that you had originally had there. So if I can decrypt some of the words, then I can start attacking it that way, trying to figure out which encryption routines generate that same encrypted text. Frequency analysis is in the English language, E, T, A, and O are the most common, while Z, Q, and X are rare. Likewise, T, H, E, R, O, N, and A, N are the most common pairs of letters, termed bigrams or digraphs, and S, S, E, E, T, T, and F, F are the most common repeating letters. This is where it all starts. So you start trying to put these pairs together and encrypting them and see which encryption pieces match in that letter. If you see frequency analysis where they're coming up stochastically close to being the same number of frequency, then you can start attacking the text that way. So this is how they did it in World War II against the German Enigma ciphering. The Vigenère cipher is also going to be on the test, and it's using a series of Caesar ciphers to form a simple polyalphabetic substitution. So you can see the Vigenère square, which is a key plain text and ciphertext. So the Caesar cipher, so this the Vigenère is using a series of Caesar ciphers. Well, what is a Caesar cipher? It's known as a shift cipher, a substitution cipher in which each letter of the plain text is replaced by a letter some fixed number of positions down the alphabet. In other words, for example, with a left shift of 3 would mean a D. Would mean a D would replace an A. So if you rotate 26 letters, you end up with the original message. So if you rotate 26 letters and the A is replaced with an A B is replaced with a B because there's 26 letters in the alphabet. So if you're going to shift 3, then A would become B, C, D. So every A would become a D. So that's how you shift and replace. So that's what a Caesar cipher is. So if we go back to Vigenère, it's a series of Caesar ciphers. So you replace with a 3, then you do it again. And there's a table that produces those transforms. So plain text, the quick brown fox jumps over the lazy dog. The ciphertext is this, QEB, NRFZH. That's what it would look like. A ROT 13 is a rotate by 13 characters. It's a simple letter substitution. It's a special case of the Caesar cipher because if you take a Caesar cipher where we rotate 13 letters down, and then if we rotate 13 plus 13 is 26. So if we rotate 13 down and we do it again, we end up with the same original alphabet. So if you use a Vigenère of rotation 13 or ROT 13, and you do it 2 times in a series, you know, you might translate 1, 2, 3 times. You rotated 3, rotated 3, rotated 3 again, and that's what you end up with your ciphertext. So to undo that, you would unrotate by 3, unrotate by 3, and unrotate by 3 again. Hopefully that makes sense. So if you rotated twice with a ROT 13, then you end up with the original Caesar, with the original ciphertext. So for substitution, you can replace one character for another. So a simple substitution is just say for every A, we're going to replace it with a D. For every Z, we're going to replace it with a B. So for data centers, we're going to discuss humidity. Humidity can be a real problem in a data center. So if the humidity gets above 45 to 50% relative humidity, the electronics can short out or corrode. If the humidity gets below 45 to 50, the relative humidity causes static electricity to be a problem. Static electricity can destroy components. So low, 45 to 50, that's static electricity. Above, we have shorts and corrosion. Binary to text encoding. Binary to text encoding. So let's talk about this. So we represent binary data in ASCII formats. Base 64 is the most popular encoding mechanism today in malware. So they like to, base 64 encoding versus encryption. Encoding is very quick to encode and decode. It doesn't take a whole lot of CPU cycles, where encryption takes a lot, and also those XOR operations kind of give away that something's going on there. So the base 64 is a little easier to do. So most malware will encode, base 64 encode URLs and things of that nature to give them a little bit of obfuscation. So there's some online decoders and encoders. When you find a rogue email, it looks like it's encrypted, but it's really encoded. Then you can throw it in a base 64 decoder and just kind of take a look at what URLs they're trying to throw around there. If you have emails that are coming into your organization from phishing attacks, you can decode the URLs and then stick them in your endpoints to say, hey, whenever you see someone trying to go to this URL, no, route it. Don't let it go anywhere. So MIME encoders are used for email attachments, or MIME encoding is used for email attachments. MIME encoding is another type of binary to text encoding, or text to binary encoding. Common use is to fool security analysis tool for sending data over the wire serially. So they kind of obfuscate the information a little bit. If they can change the signature a little bit, then the egress points, the devices sitting out on the egress points when they're looking at the traffic will kind of miss it because it was encoded. These things don't try to decode anything. They just look at serial text coming across the wire. We talked about this when we talked about the ciphers. Substitution is an encryption mechanism where one character is replaced by another. You'll see a test question on this. An encryption method where one character is replaced by another. You're actually not encrypting anything, you're just kind of more like encoding it. But for the test, it's an encryption method where one character is replaced by another.